Vitamin D3 induces tolerance in human dendritic cells. In this case, they go on to say by activation of intracellular metabolic pathways. Let's look now at component number 3 of these external barriers. These are the intracellular junction proteins. These include more than 40 different proteins, and just like all other proteins, they are especially dependent on zinc and protein intake. Among the different intracellular proteins, some of them block passage, and so they function kind of like cement or mortar, and others simply hold the cells together but without creating a seal, and so they function kind of like wall ties. And these include zonulin, zona occludens proteins 1 and 2, cadherin and ecadherin, occludin, and vinculin. In experimental models using human colon cancer cell lines, treatment with vitamin D increased the expression of some junction proteins, including zona occludens 1, zona occludens 2, occludin, ecadherin, and vinculin, leading to decreased membrane permeability. And that information was actually recently published in Frontiers of Nutrition 2020 in December. So that's not even a year old. So now let's take a closer look at that exact same article, Zinc, Vitamin D, and Vitamin C, Perspectives for COVID-19 with a focus on physical tissue barrier integrity. You can see the authors state, besides immune cells, the vitamin D receptor is also found in pulmonary epithelial cells. When activated, VDR results in the expression of defensins and cathelicidins. Those are antimicrobial peptides. Those are peptides with antiviral activity through direct action or immunological modulation or immune modulation. They also state that by knocking out the function of vitamin D, animals exhibit increased lung inflammation and impaired lung function, which can be explained by the increased pulmonary permeability resulting from impairment of the integrity of the epithelial barriers. Thus, in vitamin D deficiency, the lungs lose epithelial integrity, becoming more susceptible to inflammatory processes and pathologies such as asthma, chronic pneumonia, and cancer. And you can see this really nice diagram from their article talking about those intracellular junction proteins, here divided into 3 categories: tight junctions, which are affected by zinc, vitamin C, and vitamin D; adherens junctions, which especially need zinc and vitamin D, and also the desmosomes that are mentioned here. So you can see these tight junctions actually seal ions and fluid transfer, typically water. So tight junctions block ions and fluid, whereas the adherens junctions don't block fluids or ions, but they just hold the cells together, kind of like wall ties. So again, this is kind of like the mortar between the cells or between the bricks, and this is that metal wall tie that I showed you earlier, holding things together but not blocking ions and fluid. And so what we're aiming for conceptually and clinically is to improve the strength of this barrier to block invasive microbes, especially bacteria and viruses, to block them from bypassing these external barriers. So we want to strengthen these barriers in every possible way that we can. That includes strengthening the cells and also strengthening the gaps between those cells, the intracellular junctions. Also, we want to promote tolerance in the immune cells that are below these epithelial cells, because if those immune cells get activated, they will trigger inflammation that will lead to disruption of these intracellular junction proteins, and that will lead to leakiness. And we're all familiar with the concept of leaky gut, and that's what leaky gut is: disruption of these intracellular protein bridges or gaps, or in my metaphor, wall ties. So we need to keep these bricks or these epithelial cells tied together, otherwise we're going to see leaky gut or leakiness of other areas such as the mouth, respiratory tract, or genitourinary epithelium. Let's look at one more article on the same theme, vitamin D3 versus gliadin, which of course is a protein found in gluten, such as in wheat, barley, and rye. And so what they're proposing here is that by strengthening those barriers, we may actually be able to reduce the incidence of allergic diseases generally, and in this case, specifically celiac disease. So you can see that this was published in Digestive Diseases and Sciences 2018. Vitamin D is a health-promoting molecule involved in different biological processes and potentially preserving the tight junction structure. Vitamin D metabolite calcitriol, the active form, so to speak, of vitamin D3, prevents the tight junction damage induced directly by gliadin in vitro and in a certain animal model. The findings related to intestinal barrier damage and the benefit from vitamin D use suggest its application in other gluten-related disorders, such as non-celiac gluten sensitivity, where the presence of altered intestinal permeability is proven. So again, this goes back to the image that I just showed you. We're trying to preserve the integrity of first the epithelium, then controlling inflammation that would otherwise be driven by the submucosal or intradermal immune system. And here we're trying to focus in on maintaining the integrity of those junction proteins. When those junction proteins get compromised, that leads to leakiness of these external barriers, the most famous of which is increased intestinal permeability, more commonly known as leaky gut. Let's look at another example on the following page. Vitamin D deficiency contributes directly to the acute respiratory distress syndrome. Also another article showing that vitamin D supplementation provides clinical benefit in patients with COVID-19. Also very well known by now is the fact that patients with severe ARDS, acute respiratory distress syndrome, or those requiring ICU or intensive care unit treatment are frequently very severely deficient in vitamin D. Moving on now, let's go to component number 4 of these external barriers, which are the antimicrobial peptides. These antimicrobial peptides promote lysis of viruses, bacteria, fungi, and cancer cells. They are either pro or anti-inflammatory, but mostly we can consider them to be immunomodulatory. Here from 2017, we see the antimicrobial peptides